So now, principles of pulse field electrophoresis. So carefully listen. Conventional approach electrophoresis cannot separate the linear double-stranded DNA molecule that have radius of gyration, which is larger than the pore size of the gel. So what is called radius of gyration means, if you are taking the larger size of DNA to separate the small pore size. Compared to approach electrophoresis, so we are using only small size of DNA fragment. In the case of pulse field approach electrophoresis, we are using greater than 30 kb size of DNA. So the size of the DNA is greater than the actual pore size of the gel. The time the given DNA or large size of DNA are never migrated. So this time some of principles are added. It's called radius of gyration. This radius of gyration is the physical phenomena, and if the DNA molecule try to separate through the pore already present in the gel, but it cannot migrate. That time we are applying some force from the single axis. So that force will drive the separate the DNA from cathode to anode. This is called a radius of gyration. This is very basic principle of physics, but here is applied. Okay. These large linear duplex DNA molecule migrated through the acrogel at the same rate, irrespective of size. In other words, acros ceases to exercise any molecular sieving effect on the large duplex DNA. So the time the DNA molecules are trying to migrate, irrespective of size. So the time the molecular sieve effects are created. Yes. For avoiding this molecular sieve effect, we can fragment the genomic DNA. So before we are applying prepare the sample for pulse electrophoresis, we can collect the entire genomic DNA. After that, we digested the DNA. Finally, we separate the DNA according to their size. Okay. This behavior of large DNA molecules because of phenomena is called repetition. Repetition means, you know very well, the word derived from reptiles. You know, reptiles are linear organism. It can easily migrate wherever it wants. Likewise, DNA as a linear DNA, if you take a linear DNA, it can easily migrate if the pore size is less than the DNA molecule. Okay. This process are collectively called repetition. Which means that the molecule migrates on the matrix. Anyway, the linear DNA molecule gets migrated if the pore size is lesser. The time the molecules look like a snake. Yes. This problem is mainly arised in the pulse field electrophoresis. Okay. So what we do, so we can rectify this problem. We can easily increase the pore size is the only way. Okay. But if we are increase the pore size, we are automatically using the low concentration of agarose. Yes. So these large pore gels are capable of sieving larger DNA molecule. The molecular sieving being as a function of pore size. Okay. Thus, extremely we are using low concentration of agarose, especially 0.1% to 0.2%. Yes, this concentration of agarose, we can make the gel have some problem. So for example, if the gel easily get fragile, and also we handle extremely careful, and also the DNAs are get migrated very slow, followed by we cannot get good resolution, and incapable of separating the linear DNA molecule. The whole size is the excess of 750 kb size. Yes. Suppose some of the DNA after fragmentation, some of the DNA may be greater than the 750 kb size, so we cannot easily separate it, because the 0.1% to 0.2% of agarose only allow the less than the 750 kb size of DNA. So greater than 750 kb size of DNA are not separated, stay at the sample well. Okay. So in that condition, then how we separate the greater than 750 kb size of DNA? Yes, the question is arised. So now we are employing the pulse field electrode. So we can change the direction of field varied continuously during the electrode. So this only alteration of changes of direction of electric field to separate the greater than 750 kb size of DNA. So how we separate? This is achieved by alternatively turning on or off the current or pulsing the electric field in a short time intervals. It's called pulse time. Pulse time means we are changing the current, we are changing the direction of current at a short interval of time. This time is called pulse time, otherwise called TP. How it provide? An array of electrode is arranged around the gel, such as direction of electrophorese may be continuously varied. So we can arrange the various direction of electric field. So finally we can achieve this way. The pulse of electricity are passed through the electrode for some time in the range 0.1 second to 90 minutes before changing the direction of the field and passing pulse of electricity through the field in the new direction. Okay. So we can take the three directions. One is left, one is center, one is right. So first we given the pulse to the electrode for 0.1 second to 90 minutes and one direction. Maybe take a left. Yes. So after the corresponding time, we can changing the electricity to the electrodes at the center. So after some time, we can change the electricity to the right side. So by this way, we can change the pulse of electricity through the new direction, continuously, periodically change the electricity. Okay. So this is the only solution to separate the given DNA fragments, even if the pore size is less. So by this way, the direction of electrophoresis of DNA is constantly alternate between the two electric field direction as a molecule reorient. It's a very important phenomena. It's happening at the time of pulse field electrophoresis. So this reorientation means the reorientation angle is changed. Finally, the molecules get migrated. The reorientation is important phenomena. This reorientation was created only the direction of applied voltage. Yes. Okay. During the electrophoresis, the molecules are reoriented according to their pore size or according to their size of the sample. In this regard, this pulse field electrophoresis is classified into two types. One is biased repetition model and caterpillar model. The two type of migration is there in the pulse field electrophoresis. How means? First we take the biased repetition model. I'm already told repetition means the movement of DNA look like reptiles. Okay, this is the first we consider the DNA oriented transverse to the direction of the electric field. This is considered as a gel, the gel containing pore. So this DNA oriented transverse to the direction of migration. So this DNA goes to reach the pore, so it can never migrate. This is the one direction. This is the DNA oriented direction to the electric field. So the orientation of the DNA is transverse and is similar to the direction of the electric field. So this is a linear DNA. This is electric field direction, and also this is considered as a gel pore. So the DNA get migrate. DNA enters the pore regardless its more molecular mass. So consider this too. The pore size is small, the sample size is big, but the orientation is different compared to this. So this time the large size of DNA fragment get migrated the time of electric field application. This is culturally called biased repetition model. Compared to caterpillar model, caterpillar is well-known insect. This migration look like caterpillar. Okay. This is the electric field direction. Okay, please keep your mind. And also this is the agrogel fiber, which contain pores. And also this is the considered DNA sample. This is bigger size than the agrogel pore. Okay. And how it's migrated? First we take the DNA extend in the U shape. How the U shape is formed? Because the electric field direction is this like. So here cathode is there, anode is there. The anode will attract the DNA molecule. So the DNA may be form a U shape. The U shape contains our gel beads. Okay, then followed we continuously applied the electric field. The head side of the DNA sample once again pulled out from cathode to anode. This is considered as a DNA sample head. This is a DNA sample tail. This is only considered for the DNA sample alone. Okay. Once again the electric field we are applying, so it's continuously pulled out from the cathode to anode. Followed electric field application, the head side of the DNA get extended more because this side of the DNA is larger than the tail side. Okay, this DNA get even pulled, so the larger size of fragment get even pulled out from cathode to anode because we are applying voltage. The head explore new route through the gel. So finally, after that, the head side of the DNA try to find out the next pore of the gel for migration. Okay. The tail side of the DNA get reduced. Finally, this form will look like this. The extent of head side is too high. The tail side of the DNA get reduced, followed by longer arm pull chain formation. So once the head side is once again pulled out, the tail side comes out. So the U shape converted to linear form. Yes. Followed by electric field application, the DNA gets migrated from the pore. Yes. This is considered as the one pore. The head side of the DNA to find out the another pore. Yes. So another pore, same process is happening. Finally, the large size of DNA molecules are migrated through the small size process in the gel matrix. This is collectively called caterpillar model. Okay. This is very important points. Please listen. Actually, the precise reason why the large DNA fragments are separated so well on the pulse field regions, it's not yet fully understood. Yes. But even the small pore size, why we try to separate the large molecules in the small pore size, this question still arises. For this question, we can try to give some answers. What is called means, it is the thought that, yes, during the reorientation, the helical structure is stretched and then compressed. These two processes are collectively called reorientation. This stretching and compressing is a phenomena. Is called reorientation or reorientation of angular DNA molecule. Why the molecules are get reoriented for the effective migration? So this orientation phenomena take some time. This time is called viscoelastic relaxation time. So viscoelastic relaxation time is TR, simply called TR. This entire phenomena is called viscoelastic relaxation time. This time is dependent on the molecular weight of the DNA. Suppose the molecule is too high, the relaxation time is very large. Similarly, if the molecule is too short, the relaxation time is very short. So this time based on the molecular weight of the DNA. Okay. Now, small molecules reoriented themselves to the change electric field much more quickly than the large molecule. Yes. This reorientation process happening very quickly in the case of small molecules. The case of large molecular, the reorientation takes some time, which means that the later have less time available to electrophorese during the given electric pulse. And also for large molecule separation, the smaller molecules are migrated more faster, but the large molecules are migrated very slow. So we are providing as much of time to the separation, even the changes of direction of electric pulses. Okay. According to the large molecule, the migration is slower in the gel because the pore size is small. Okay, you know very well. And also the viscoelastic relaxation time is also too high. But the small molecules are get easily migrated more faster. Even small molecules are get also reoriented, easily find out the pore and easily get migrated regarding their molecular behavior. Okay. So this only we are considering the large molecule, the migration is very slow. For the time we are considered the ratio of viscoelastic relaxation time to pulse time. These two time is more important crucial for separation of pulsable electrophorese. And also if you are considering this area, we can got the good separation if allowed. So this is the main important principles behind the pulse field electrophorese. Please listen. The TR means viscoelastic relaxation time. This TP means pulse time. Once again, I am telling you, viscoelastic relaxation time is the means the DNA get reoriented by stretching and compression. This is called the time for this process called viscoelastic relaxation time. This is pulse time means we are switch on and switch off the current, or periodically we are changing the direction of the field. The time of changes of periodical direction is called TP. Both are very important in the case of pulse field electrophorese. Please listen. If the pulse time is much shorter than the TR, that means viscoelastic action time, then there are insufficient time. This is the insufficient time for the molecule to orient itself in the response to the pulse. So here the alternative switch on switch off the current time, that means pulse time, is much shorter. Means what's happening means, so the molecules are insufficiently reoriented because the time is very short. So for this small time, the larger molecules are not effectively reoriented. So against the response to the pulse of electric field. That's why I'm saying the pulse time is much shorter than the relaxation time. Come to here. If the pulse time is much larger than the viscoelastic relaxation time, then the molecule will behave as a conventional across electron. Yes, because we are giving a much more time. So the molecules are get easily reoriented through by the pulse or current, reoriented. So we are providing much time. The molecules get effectively reoriented. But that time the molecules are behave like a conventional electrophoresis because easily migrate. Small molecules are more faster than the large one. Okay. Even these two conditions, the large molecules will not separate according to their mass. Even though the large size of molecules are never separated based on their mass. Then what we'll do? Then we create some ratio. How much time of we are giving the electric field and how much time of we are switch off the current. How much time of we are giving the electric current, or how much time of we are periodically change the voltage in the matrix and in the pulse electrophorese. And how much time of we are not giving the electron. This is called reorientation time. It's called reorientation time. This is a relaxation time. It's called relaxation time. This ratio is more important for achieve the good separation. Achieve the good separation. For example, if you are giving the TR, that means relaxation time is 0.1 and the pulse time is 1. 1 means you got maybe optimal separation based on the if the molecule is too large. Suppose the TR is much longer for large molecule, this means the pulse time as little as 0.1 second are adequate for separation of molecule for 10 kb size of DNA. Where means if you are giving the switch off condition, this condition otherwise called relaxation time. The time is much longer, and the pulse time is 0.1 second. So this very simple, very small time, this time small size of molecule are easily get migrated because the pore size is normal. In the case of large molecules, we are giving the pulse time is 1000 seconds are required. That means pulse time means we are switch on the condition, the time of switch on. It's called pulse field. This field condition we have 1000 seconds are required with the mass range approaching 10 mp. This is a huge size of molecule. Some of the factors also affect the rate of migration in the pulse field electrophoresis. Likewise, DNA molecular mass is a major factor to affect the rate of migration, and also we are providing electrical strength, field strength, which contains voltage, current, and resistance. So you know very well. So if you want these factor affecting, you watch my YouTube channel, the corresponding video. Okay. And also the one more factor is the reorientation. The reorientation is important. Is faster in the stronger electric field. And also we determine the rate of reorientation. It's called TR. Okay. And also gel concentration. This is the concentration of agarose to determine the pore size. Is if you are maximum giving the pore size that can allow the medium up to 750 kb size of DNA. Okay. Temperature is more important here because we are giving long time. And long time for separation of long size of molecule, and also we are giving the alternative time for pulse time. Yes, so we are so much of time is taken. For time, the buffer also maybe get warm, the temperature is increased, and the further consequences takes place. Okay, the orientation angle is more important. If the DNA is linear, we can easily separate it either biased repetition model. Yes. If the DNA is another unshaped DNA means you can the principle obey the caterpillar model. Yes. So the two reorientation angle is more important. Moreover, this is considered as a pulse field across gel. This places a sample well, and we are placing DNA fragment and various size. It contains large size and small size. First, we apply the voltage, field direction. Yes. So change the direction of electrophoresis like this, followed by this, followed by this, followed by this, followed by this. Finally, zigzag migration takes place. Finally, the DNA sit in linear band according to their molecular mass. Yes. Finally, we can stain and easily data interpret. This is the usually cathode. This is the anode. This is the cathode. Opposite.